A very good afternoon to everybody out there. What a wonderful Thursday afternoon to spend some time with mathematics. I want to say welcome to the session. To those of you who've been with us the whole week, we salute you. We see you are serious and we are very excited to host this webinar again this afternoon. Welcome to the session. If you are wondering what the 21 Acts of Goodness is all about, I want to just share with you that Old Mutual Foundation launched the 21 Acts of Goodness to enable you guys, the matric class of 2020, by providing some extra support and encouragement to all of you. Now, when this was launched, Macmillan literally grabbed the opportunity to support the class of 2020. And today we want to show all our matrics attending this math revision session that with their important final exams around the corner, be assured that Macmillan has got your back. All the 21 Acts of Goodness partners are also there to support you. And we're not only supporting you, we are also there to support all the teachers and parents out there. Now, if you are struggling to apply your knowledge in maths, specifically Euclidean geometry this afternoon, you are definitely at the right place this afternoon. We know you can do well in maths this coming exam. Now, just for those who maybe attend for the first time, there's a control panel on the right side of your screen. If you want to download our materials, all those wonderful activities with the answers, you just need to go to the little wheel there where you can download, and also make sure that you can hear us clearly with the audio function. We also want to invite you guys to please chat with us. You will be doing activities with our presenter, and he wants you to respond. He wants you to comment. He wants you to give answers. So if you look at the speech bubble, that will be the chat option. So any question, any comment, any answer, please don't hesitate, participate. We want to really invite you to do that. Our presenter, some of you have met him earlier in the week, is Sego Matlala. Now, Segu, you know, if you look at him and his face, you will almost see experience and passion for mathematics your way. He's got 23 years of teaching and lecturing facilitation experience, including project management roles. And I know you all can't wait for this year to be over and done with so that you can join a university or a TVET college. Segu is currently a maths lecturer at the University of Joburg. And he also is part of the Macmillan Teacher Campus family, where he's been running projects for us to support learners programs out there. So Segu, thanks for setting maths on fire this afternoon. Thanks for sharing your passion. And I want to say thank you so much for your wonderful way of dealing with all these activities and encouragement that you're passing on to your learners this afternoon. I'm handing over to you. Enjoy the session with everybody. Thank you so much.
Thank you, Martha. Good afternoon, students. We are happy that you joined us today in this session. Today's session will be on Euclidean geometry. So we will look at Euclidean geometry. So there are tools that you need to know in Euclidean geometry, like any other topic, like the tools of any other topic. So geometry has got also its own tools. You'll see that the geometry that you are doing in grade 12 is the geometry of the circle and the geometry of the triangles. Because the geometry involves circles, therefore you need to know the parts of the circles. So here, most of you, I know that you are familiar with this, but this is just to recap, just to refresh your minds. So if you look at the diagram, you have got the straight line AF. Look at the straight line AF in the circle with center O. That's the straight line AF. So the circle is circle O. We name the circle using the center of the circle. So in this case, I call this circle O because the center of the circle is O. So the circle has got the straight line AF. The straight line AF is called the chord. I think you are familiar with that. Then you also have the straight line AKF. You also have the straight line AKF, which is your arc. So the arc can be any portion of the circle. It can also be AC, that's your arc. The arc also can also be the portion HD, that's the arc of the circle. So if I say the arc of the circle, I'm referring to the part of the circumference of the circle. Now CH is your diameter, that's the line CH. CH is your diameter. Remember that the diameter is a line that always passes through the center of the circle. That diameter is very important. Remember that a diameter is a line that passes through the center of the circle. You also have the secant. Look at the secant. What is the secant? The secant is the line BE. The line BE is your secant. So the secant is the line that cuts the circle. It cuts the circle, say, into two portions, or it divides the circle into two parts. Okay, look also at the radius. The radius also is one of the lines that are very important. So you will meet them also as we discuss the problems of Euclidean geometry. The radius, remember, it's a line that starts from the center of the circle to any point on the circumference of the circle. That will be your radius. So in this case, OH can be your radius, OD can be a radius, GO can also be a radius, as well as OD. OD can also be a radius. So the line OH is a radius, the line OD is a radius, and by definition, a radius is any straight line that starts from the center of the circle to the circumference of the circle. And lastly, we have got a tangent. The tangent is a straight line that touches the circle only at one point. All right. So I just went quickly through these lines or through these definitions because I assume that most of you are already familiar with these terms. Right. So I'm just going to clear that out. Remember, ladies and gentlemen, remember, learners, that in Euclidean geometry is made up of axioms, it's made up of theorems, it's made up of definitions. So to be able to perform well in Euclidean geometry, you need to know those theorems. You need to know those axioms. You need to know those definitions, because you will apply those theorems, you will apply the axioms, you will apply the definitions in solving geometry problems. So I'm just going to go through now with some of the axioms and the theorems that you will need in order to solve problems. Okay, here I've presented three diagrams or three theorems, circle and center theorems. So we have divided them into four. These are circle and center theorems. So the diagram one, you're familiar with this already. No, I'm just gonna have this. I've pressed that by mistake. I must go back again. Yeah. Look at diagram one. Diagram one says the line drawn from the center of the circle is always perpendicular to the chord, and therefore it will bisect the chord. It says any line drawn from the center of the circle, suppose that is the center of the circle, and if this line is perpendicular to the chord, so in this case, your chord can be the chord AB, just gonna put it like that, can be the chord AB. So the theorem says a line drawn from the center of the circle perpendicular to the chord will always bisect the chord. Please remember that whenever you see the center of the circle, check whether you don't have a line running from the center, say, to the chord. And if this line is perpendicular to the chord, it means that it will be bisecting the chord. Bisecting the chord, I mean that this side will be equal to that side. That's what is meant by bisecting. Okay, the other important theorem is theorem number 2, or diagram number 2, that states that an angle subtended by a diameter is a right angle. So in geometry problems, whenever you see a diameter, like in this case, there is a diameter, follow the diameter and see if the diameter doesn't form any angle of 90 degrees. You see, in geometry, you will see one part, then you'll need to complete the other part. Like I'm saying in this case, in the first diagram, if you see the center of the circle, check whether you don't have a line from the center perpendicular to the chord. So if you have got a diameter, check if that diameter doesn't subtend any angle at the circumference of the circle. And you will know that the angle subtended by the diameter at the circumference of the circle will be 90 degrees. Okay. Now, diagram number 3 is also a theorem which is also very important that you need to know, is that the angle at the center is always twice the angle at the circumference. You can see that, say for example, if this angle at the circumference is 20 degrees, say this one here is 20 degrees, what will be the size of the angle at the center? The theorem says the angle at the center is always twice the angle at the circumference. Now the question is, suppose this angle here at the circumference is 20 degrees, what will be the size of the angle at the circumference? Let's see what you get. 40 degrees. Owam, that's very good. Ital, you said 40 degrees. Joy also says 40 degrees. That's very good. That's very good. Langanani also, you said 40 degrees. That's good. That shows the understanding. That's very good. Okay, let's see now. Let's move to the next theorems. Okay, here we looked at 3. We call them circle and center theorems. Circle and center theorems. So you'll have a circle and the center of the circle. So that's why we call them center theorems. And remember, guys, in the examination, you will be asked to prove, say, this diagram, the theorem number 1, that one is required for proof in the examination. That one also, you must be able to do the proof in the examination. All right. So let's move to the other diagrams. These ones are cyclic quadrilaterals. Center and circle theorems, they are the ones that we have studied previously, those 3. So it's 3 circle and center theorems. Then cyclic quadrilateral theorems, they are also 3. So the theorem says the opposite angles of cyclic quadrilateral always add up to 980 degrees. So this means X, the angle X, plus the angle Y will always be equal to, I'm gonna write here, 180 degrees. Remember, I said in Euclidean geometry, you will always be given one part of the statement in the diagram. So in this diagram, One part of the statement is that, say, for example, suppose that is A, this is B, that one is C, and this one is D. No? So then we say the quadrilateral A, B, C, D is a cyclic quadrilateral. Remember, for it to be a cyclic quadrilateral, all the 4 points, point A must be on the circumference, point B must be on the circumference, point C must be on the circumference, point D must also be on the circumference. So for a quadrilateral to be named cyclic quadrilateral, the 4 points must lie on the circumference of that quadrilateral. If you have got, say, for example, something like this, say I've got something like this. If you look at that, can I call this diagram a cyclic quadrilateral? Can I call this diagram a cyclic quadrilateral? Is it still a cyclic quadrilateral, this one? Will it still be a cyclic quadrilateral? The answer, is it yes or no? If I've got that, is it a cyclic quadrilateral? No, it is not a cyclic quadrilateral. I see Joy, Ital, Haldezos, Shamila, and Langanami are saying no, 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 no. And it is because not all the 4 points are on the circumference of this circle. As you can see, this point here is not on the circumference of the circle. Then lemmas, now we are saying, if you have got a cyclic quadrilateral, like the one A, B, C, D, you must know that the opposite angles will be 180 degrees. That will be 180 degrees. Yes, Amogalang Musetla, you are saying no because 2 angles don't touch the circle. That's very good. 2 angles didn't touch that circle. And therefore, we say that the quadrilateral is not cyclic. Right. Okay, look at diagram number 2. Does diagram number 2 makes any sense to you? Diagram number 2 says the exterior angle of a cyclic quadrilateral always equal to the opposite interior angle. All right, just check very well how the diagram looks like. So that is that line there. You see that it goes out. It's extended outside the circle. And this one is a chord. That one here is a chord. So the straight line, that one, and the chord forms the angle X. So X is an exterior angle. You can see that X is outside the given quadrilateral. Then we say the exterior angle of a cyclic quadrilateral X will always be equal to the opposite interior angle. Then diagram number 2, we are saying that angles subtended by the same arc or subtended by the same chord are always equal. You look at this one. Look at this. I'm just going to erase that. Look at this one now. See this angle? Angle X. Angle X is subtended by this chord. That is the chord. So if you take your fingers, you put your finger there, or you put your pen there, you go straight to the circumference. And again, I move from that chord again, or that arc again. I move straight to the same angle X. You see that this angle X is subtended. When we say is subtended, it means it's like it's formed or it's held up by this particular arc. Then we say the arc subtend angle X. It means angle X is formed by this arc, is formed by or is held up by the arc. So if you look at this, the arc, just gonna show it like this arc here, subtend the angle X. The same arc again, subtend which angle? Follow the angle again. You say, you put your fingers or you put your pen here, you go up, then you come again the same way, then you drop it here. You see that the arc that I've shaded forms angle X. It also forms angle X. Now, because the two axes are formed by the same arc or the same chord, then we say that they are equal. All right. So if you look again at the other arc, say this arc here, this one. Look at this arc here, this one. That arc there, the one that I've shaded yellow. You see that arc. This arc can form, if you put your fingers there, you go up, is there. You go up again from the same arc, you go up, you get that one. You see that the one that is marked yellow is now formed by that arc. All right. Again, start from the end of that arc. Start from the end. Follow a straight line. Now I'm following this one. See, from the same arc, I'm following that. From the same arc again, I'm following that. So you can see that the two angles, this angle and this angle, are formed by which arc? Are formed by this arc. See the arc that I've shaded, this one. Guys, it's very important that you understand this, because when we do the problems, you might not see it clearly, but you see the way I'm following it, it might be better for you to see whether the arc subtends the angles, to see which angles are subtended by the same arc. Remember, it must be the same arc or the same chord. And then sometimes we will say angles in the same segment, because those angles there are in the same segment. Okay, let's move on. So these theorems are the cyclic quadrilateral theorems, and up to so far, we only have those three. Right, look at those theorems. These are now tangent theorems. Those are now tangent theorems. Yes, Ital, on the reason you need to mention the arc. I think it's always better to mention the arc. Say angle subtended by the same arc, and then you name the arc. Thank you, Ital. Angle subtended by the same arc, then you name the arc, because it shows understanding if you name the arc, because it shows us that you really saw the arc that subtended those two angles. Yes, state the arc where possible. All right, look at this tangent theorem. Look at this, look at the first one. Let's look at the first diagram. This line is a tangent. Remember that a tangent touches the circle only at one point. Right. That is also a tangent. So now the statement says two tangents drawn to a circle from the same point, it must be same point, outside the circle are equal in length. So it means that from this point to this point equals from this point to that point. All right. Okay, diagram number 2 says a tangent to a circle is perpendicular to the radius at the point of contact. This one, the next diagram, I see there is a question. Are we required to prove all of these theorems? Munsemi, you are not required to prove all of these theorems. There are only 4 theorems that you need to prove. I'm just going to show them to you. The theorems that you will need to prove, it will be this theorem, the tangent theorem. You need to prove that. You must know the proof of that one. That's the tangent theorem that says the angle between the tangent and the chord. Look at this one. That's your angle. The angle is formed by this tangent. You see that tangent line? That is the tangent line. All right. And also this chord. You see, it's a tangent and a chord. Now, the same chord, just gonna change that color there. Choose a pen color. Choose a pen color. What's wrong here? And then you see, guys, the chord. This is the chord that I'm talking about. Is the chord and what else? And this tangent. It is very important to see the cache there. Is that tangent and this chord. So the other angle, which is equal to this one, must be subtended by this chord. So that's where we are now. You go here, come up there. You see, the same chord, this chord, subtends this angle here. So if that is the case, then the angle here will be equal to that angle there. All right. So you will be required to prove the tangent theorem. This one you will be required to prove. That one you must be able to prove it in the examination. Then Tandega is saying I must explain diagram number 3 again. Okay, Tandega, let me explain it again. So I'm just gonna erase here, then try to explain diagram number 3. You see, diagram number 3, it says the angle between the tangent and the chord. If you look at this diagram, the angle X, look at the angle X, this angle. All right, Tandega? This angle is formed by this chord. All right. And what else? And this tangent. Okay. So you can see that the angle here, the angle X is formed by this chord and this tangent. Now, according to this theorem, is that the angle that is formed by the chord and the tangent will always be equal to the angle in the alternate segment. So that means the same angle X here will be equal to that angle X there. You see? And then what is important is that the chord in question must be the chord that subtend this angle which is in the other segment and no any other chord. That's what makes the theorem to be a bit tricky, because it says the angle here and the angle here must be subtended by the same chord. You see, the chord here forms angle X with this tangent, and the same chord forms the angle X. So when you do problems, when you solve problems, just make sure that you are referring to the same chord. I think, Tandega, I've answered your question. Thank you so much. So as Musami was saying, are we required to prove all these theorems? No, you will be required to prove the tangent theorems. I'm just gonna tick for you. This one, you must know the proof of the theorem. Then which other one also? I'm just gonna show you the others that you need to know the proof of. This one also, the angle at the center Oh, let me, is that one? Just gonna go here again. Other one that you need the proof is that theorem. Opposite angles of cyclic quadrilateral. You will need to prove. So it's the tan chord, the cyclic quadrilateral. You need to know the proof of that. Then which one also? I'm going to show you the other one that you need to know the proof. That theorem number one. This must go there. Yeah. Theorem number one, you need to know the proof also. Here you need to know the proof of this one. You also need to know the proof of this one. So you'll need to know the proofs of how many theorems? 4 for the examination. I'm referring to the circle theorems. The circle theorems, you must know the proofs of at least 4, which is diagram 1, diagram 3, then the next diagram. Let's look at the next diagram. The next diagram, which is, let's click here, which is this one also. You need to know the proof of that. This one. The others, you only need to know the wording. You only need to know the wording of the theorems. Because even though you may not be asked to prove the theorems, you must know them, because when we solve riders, when we solve geometry problems, you need to know those weights. All right. Thank you so much. Yeah, all 4 theorems that you need to know how to prove them. It's only 4 theorems. Okay. So now let's go to another tool. We go to something also which you need to know in Euclidean geometry, proportionality theorem. Proportionality theorem, you also need to know proportionality theorem. And what does proportionality theorem says? It says a line drawn parallel to one side of a triangle divides the other 2 sides proportionally or in the same proportion. A line drawn parallel, the line must be parallel to one side of a triangle. And if that line is parallel to one side of a triangle, then it means the line divides the other 2 sides in the same proportion. So here I will have a triangle, right? This is my triangle. Then I've got what? A line parallel to one side. I draw a line parallel to one side of this triangle. So this means this line is parallel to that line. That's what I've indicated here. So according to this statement, it means this line, say the line is PQ. You see the line PQ? So the line PQ will now divide the line, say, the line AB and the line AC in the same proportion. So that is what this statement is saying. It's saying, remember, in this case, the line PQ must be parallel to the line BC. So what you look at here, remember, as I've said, in Euclidean geometry, you know one side, you will be given one side, then you complete the other side. So in this case, if you know that the line PQ is parallel to the line BC, that will mean say, for example, AP, I'm just gonna put here AP, I think some of you knows that, AP divide by, say, PB, just giving that, you get that ratio. This is what we call a ratio. That will be equal to, Remember on this side I said AP divided by PB. So it will be equal to what? AP divided by PB, according to this theorem, will be equal to what? AQ divided by Kilelo Masuku, that's very good. Langanani, that's very good. This will be equal to AQ. Shamila, that's very good. You also got it right. Godfrey Nube, you also got it right. That's very good. This is what is called proportionality theorem. Monsemi, you also got it right. That's very good. That's very good. Okay. All right. So I'm just going to clear that out. Just going to clear that out. Move that. Then continue. Can you read that? Can you read that statement there? Miponi also had answered the previous question. AQ divided by QC, that's very good, Miponi. You read the question? You read the statement. It says in triangle ABC. Where is triangle ABC? Let's get triangle ABC, guys. Triangle ABC. There you are. That's my triangle ABC. Remember, as I've said from the beginning of this week, I've been saying, make sure that you read the statement because most of the answers are in the given statement. So in this statement, it says in triangle ABC, that's triangle ABC. So Q here must be B. Just gonna change that Q. Q here must be B. That's an error. This must be a B, not a Q. So it is triangle A, see A, B, that's the given triangle, C. All right. In triangle ABC, what is happening in triangle ABC? Oh, Miponi, already you gave me the answer. That's very good. So it means that I'm very slow. Miponi already gave me the answer here. Thank you very much, Miponi. The others also tried to give me the answer. What do you think the value of X is in this case? Miponi already got the answer. What do you say, others? What do you say? What's the answer there? Oh, everybody said 6. Godfrey, Monsami, Tandega, X equal to 6. Thank you so much. Very good, my students. You are doing so well. Ital also says X will be equal to 6. That's very good. So that's very good. You are doing so well. So that's the triangle, and it was given that AP, no, I'm just going to do that. It was given that AP equal to 12 centimeters, AQ 12 centimeters. I see Langanani also got X equal to 6. QC is 8, PB is X. Find the value of X. We're finding the X value in this problem. And I see that most of you already got that X value. So for those who might still be wondering what X is, that's how we obtained the X value. You see, I used proportionality theorem. I used proportionality theorem to find the X value. Remember, I said that point here it's point B. So I used proportionality theorem. I used proportionality theorem because I noticed that the straight line PQ is parallel to the straight line BC. Because the two straight lines are parallel, that one is parallel to this one, then it means I can apply proportionality theorem. Then it means I'm allowed to say 12 divided by X is the same as, say, 8 divided by 16. then your X value will be 6. That's very good. And then remember, always give the reason. Line parallel, one side of a triangle. Line parallel, one side of a triangle. That's very good. Similarity theorem. Read the statement with me. In similarity theorem, you will be given two triangles. You compare two triangles, it's like incongruency. Similarity, two triangles are equiangular. What do we mean when we say two triangles are equiangular? What do we mean when we say two triangles are equiangular? What do you think is the meaning of equiangular? Let's see. Angles are equal. Shamila, that's very good. Tandega, good. Joy, good. Everybody, okay, you got it right. Tandega also says equal angles. Sami also says equal angles. That's very good. When we say two triangles are equiangular, it means their corresponding angles are equal. Halbezos, that's very good. What is important here is that corresponding, the word corresponding, it's very important in this case. Corresponding angles must be equal. Corresponding, equiangular means corresponding angles must be equal. The angles must be corresponding. It cannot just be any other angles, all right? The angles must be corresponding. By corresponding, I mean this. Godfrey also say equiangular means corresponding angles must be equal. It means that if I've got these two triangles, say that's the first triangle, I've got the other triangle here, all right? That's the other triangle. So this angle must be equal to that angle. That's the meaning of corresponding. Ne? This angle also must be equal to that angle. And also this angle, this one, must be equal to that one. That is the meaning of corresponding. So for two triangles to be equiangular, the corresponding angles must be equal. So according to this statement, it says if two triangles are equiangular, like these ones here, then their corresponding sides are in the same proportion. So this side divide by that side, it can be equal to that side divided by that side. So the sides also must be corresponding. And if that happens, it means that the two triangles are similar. And this is the sign for similar triangles. To show that triangles are similar, we use this sign. This is the sign that we use to show that triangles are similar. So we say, when we prove that two triangles are similar, we only prove that the corresponding angles are equal. We only prove equiangular. Think you hear what I'm saying? I'm saying that if you are asked to prove that two triangles are similar, so you're asked to prove that two triangles are similar, you only show us that three triangles are equal. Remember, those three angles must be corresponding angles. Actually, you only show that two corresponding angles are equal, because the third angle, it will be obvious. So what I'm saying is this, like if you have got the, say for example, You've got this triangle. So they're asking you to show that or to prove to us that the triangles are similar. So you only show us this. You'll only show us that, say, this angle equal to this angle. If you can show that, that will be fine. And also you will show that this one equal to that one. All right. So if you can only show these two, then the other one, you're not even, it's obvious because these are the remaining ones. And then you will say the two triangles are similar because they are equiangular, or because the three corresponding angles are equal. All right. Good. All right, let's see what's next now. Are the following pairs of triangles similar or not? Give me a reason. Are these two triangles similar or not similar? Tell me whether they are similar or they are not similar, the first pair. What about the second pair? Let's start with the first pair. Are the triangles ABC and PQR at number 1 similar? No, they are not equiangular, not similar. First pair, yes, corresponding angles are equal. Haldezos. Who else? They are similar. Miponi says they are similar. What are others saying? It's similar, equiangular. All right. Thank you so much for the responses. Yes, they are. Thank you so much for your responses. The first pair, let's start with the first pair. Pair 2, they are similar. Ital, Oam, Ambe, not similar because their corresponding angles are not equal. Yes, that is true. All right, let's get the official answer now. You see in the first diagrams, né? In the first diagrams, are the corresponding angles equal? Corresponding angles is that is angle A equal to angle P? No. Is angle B equal to angle Q? No. Is angle C equal to, say, angle R? No. Because the corresponding angles are not equal, therefore, the diagrams, the triangles A, B, C, and triangle P, Q, R are not similar. Remember, for them to be similar, corresponding angles must be equal. The two triangles must be equiangular, equal triangles. All right. So it says in the first angles, just rotate it. That's Haldozes. Yeah, I understand that if you rotate it, yes, then they become similar. But as they are, they cannot be similar. We don't do rotation. You make a conclusion by first look as they are presented. But say when you rotate the other triangle, it corresponds. Miponi, that is very good. If you rotate the triangle, yes, they correspond. But in this case, you make a decision whilst they are in this standard form. Remember, when you solve riders, learners, you don't make constructions. Ne? When you solve riders, you don't change anything in the diagrams. You work with the diagrams as they are. They expect us to see the rotation in exams though. That is very good, Ahildazos. You can do the rotation in the exam. Yes, you can do the rotation, but in this case, if you rotate this, then it means that you are changing the question. Yes, in the exam, there will be questions whereby you need to do the rotation, but in this case, remember, in this case, Ahildazos and Mipone, I think, if you rotate the second triangle, it means that you must also rotate this one. All right, but remember, when you solve riders, you don't do any, you don't change the shapes. The shapes must stay as they are. Even if you do rotation, remember, if you decide to rotate the second one, I'm referring to this one, you must also rotate this one and then make a decision. All right. Okay, I think that clarified everything. Yes, you need to know rotation, but in this case, the two triangles are not similar because as they are, remember you make decision as they are now. Aldazo says BACRQP. Oh, yeah, yes, but yeah, you see now, if you rotate number 2, you also rotate number 1. Yes, they end up being similar, but you cannot rotate. They will never end up being similar because if you rotate this number 2, you rotate number 1. Still, that's what is given. They will never be similar. Remember the definition of equiangular, guys. I said that the term corresponding is very important. The term corresponding is very important. That is why in the statement, the term corresponding is there. Corresponding means that you don't rotate, you don't do anything. As they appear, make a decision. Corresponding angles, corresponding sides, as they appear. Now, what about number 2? Diagram number 2, I mean this one, question 2, are number 2 similar? You see, are they similar, these ones? I think this is a straightforward question. It's yes. You see number 2, I agree. When you say diagram number 2, they are similar, I agree 100% with you. Haldazos, Mwiponi, Kakiso, Langanani, you are saying yes. I agree with you. The second diagrams are definitely similar. And why are they similar? Because corresponding angles, you see corresponding angles. There comes corresponding angles. They are equal. Corresponding angles are equal. So then the triangles are similar. You see, here there is no question. Remember, when you prove or when you answer writers, you don't change the diagrams. You make a decision as they are. If you rotate, you can rotate the whole textbook or the whole question paper. Rotate the whole question paper. That one is allowed, because if you rotate the question paper, it doesn't matter. But don't shift the figures, because when we solve riders, we don't do constructions on the riders. We only do constructions when we prove theorems. All right, thank you so much. Thank you so much to that one. Okay, there are 3 types of questions that you'll find in the exam. Basically, there will be 3. You will be asked to find the x in Euclidean geometry, number type questions whereby you have got given the angle, say angle A is 30 degrees, angle so and so is 45 degrees, and you'll also be required to prove. So these are the 3 types of questions that you might find in an examination, that you'll find in an exam. X type, whereby you are asked to find the other angle, which is x. Numeric type is whereby you are given, say, one angle is 30 degrees, the other angle is 68 degrees, and so and so. Then the 3rd type of questions in Euclidean geometry is the proof type questions. So for the examination, you must be ready and prepared to answer those types of questions. Okay, dealing with geometry questions. How do we deal with geometry questions? Number 1, never assume that an angle is 90 degrees if it looks like it. It has to be statement. In Euclidean geometry, we don't assume, all right? Never assume that a line is a diameter unless you are told that is a diameter, correct? Number 3, never assume that a line is a tangent until you are told or you can see that is a tangent. Never do construction when solving riders. This one I've mentioned already, unless you are proving a theorem. So in Euclidean geometry, you don't make assumption. Never assume that an angle is 90 degrees unless it is stated that it's 90 degrees. Never assume that a line is a diameter. Remember that It will only be a diameter provided it passes through the center. If it doesn't pass through the center, don't assume that is a diameter. So in Euclidean geometry, we don't make assumptions, okay? So never assume that any quadrilateral is cyclic quadrilateral. You have seen this before. And then also, how do you deal with Euclidean geometry? Read the geometry statements aloud. When I say aloud, I mean read it with understanding. Don't just read for the sake of reading. You read with understanding. Number two, rephrase the statement to show that you understand the statement. Fill up the baskets. This is very powerful. Fill up your basket. By basket, I mean in the diagram, see the theorems, see if there are any axioms, see the theorems, see the converses of the theorems in the diagram. So fill up the basket. See or note what you see on the diagrams. If there are any theorems, note the theorems. Any axioms, note them. Any converse theorems, note them. This one you have seen, I was doing it when I was explaining the theorems. Trace the shapes with your fingers or with your pen. Use a pen to trace the shapes or use your fingers. You can use your fingers or a pen to trace the shapes like I was doing at the beginning. All right. And then move the book or paper in a comfortable position. Move your book or the paper in the position that you understand the diagram. If you don't understand the diagram clearly, you can move your book or your paper in a comfortable position whereby you can read the diagram easily. Use colored pens. If you have got colored pens, use colored pens. Okay, activity 1. Let's see if we can do this activity. Complete the following so that the Euclidean geometry statement is true. Remember, in the examination, it's very important that you know those statements, the theorem statements, because they might ask you to complete the theorem statement. So it's very important that you remember the theorem statement. Let's see if you still remember this theorem statement. What do you think the missing word is? I see your answers are coming here. Langanani, Musemi, Mwiponi, Ital, Haldezos, Joy, Shamila, Naledi, Tandeka. There is only one answer that I don't agree with you, but all the answers are correct. I see Nyasha also posted the answer. Nyasha said perpendicular. Mwiponi also said perpendicular. Munsami said perpendicular. Ital, Haldezos, Joy, Shamila, Naledi, Tandega, you all said perpendicular. Langanani, the missing word here is perpendicular. So we say a line drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord. So the correct answer is perpendicular. Congratulations to everyone for getting the correct answer, for giving the correct answer. Okay, study the following diagram. This is the point A in this diagram. That's the point A. Already, learners, by just looking at the diagram, you can already see something here. You can already see something by just looking at the diagram. And remember, the diagram will tell you one portion, Then you need to tell us the other portion. O is the center. I'm just gonna put the statement, see if we are not given any statement here. That's the given statement, all right? Then you need, the question is to calculate the length of CD, leaving your answer in simplest set form. If CD divided by DE equal to 3, calculate the length of DE. In the circle with center O, okay, O is the center. Remember I said we don't make assumptions. Here we are not making assumptions because we are given that O is the center. So we all know that O is the center of the circle. That's the O. Remember guys, once you have got the center, other theorems must come in mind. All the center theorems must come in mind. All right. AB is 18 centimeters. Remember, with Euclidean geometry, like any other math topic, read the statements. AB is 18 centimeters. I see already people are getting the answers. I'm just going to read them now. That's very good. You are doing very well. So let's see the answers. All right, I see Langanani, you gave me the answer. Ital, Halbertus, Miponi, Ital also. Okay, Godfrey also gave me the answer. All right, thank you so much. I see Godfrey said 6 square root 7. Tandega said CD is 24. The Langarani says it's 6 square root 7. Ital says CD equal to 30. Haldezos also gave me the answer, 3 square root of 55. Muiponi also said 3 square root of 55, and so on. Thank you for the positive answers. I like your responses. That's very good. Okay, let's see the answer now. What's the correct answer? Thank you so much for contributing. You are doing very well. All right, let's see the answer. Remember, in this case, guys, they say calculate the length of CD. So we must find the length of CD. That's from C. I'm just gonna check here. From C to D. You see this length here, CD. That length, CD. So I see somebody sent an answer here. And a lady also gave me 3 square root of 55. 3 times square root of 55. Okay, let's see. CD, we want CD. AB is what? It's 18 centimeters. So this means that this length here will be 9. That one here will be 9. Why? Because DB equal to AD, it is given. And remember, for the fact that the line, the diameter or the line from the center, bisects the chord. You see the line from the center, OE or OD bisects the chord. The fact that it bisects the chord, it means that this angle here is 90 degrees. Remember theorem number 1. The line drawn from the center of the circle, bisecting the chord, it's perpendicular to the chord. All right, let's see the answer that I got, whether I got the answer that you also obtained. Let me see. All right, that's what I said. For number 1, we agree with that. That's what I've already said, that the line AB, remember, don't forget to give the reason. Ne? The line AB, that's your line AB. The line AB is perpendicular to the line CD. That's what I've said here. The line AB is perpendicular to the line CD. The line CD, line from center to midpoint of the chord. Because this is the midpoint of the chord since AD equal to DB. And then that's how you'll start that. And then, so DB is 9 centimeters. I've already explained that. And then, so in triangle ABC, that is the route that I took. Triangle ABC, triangle DCB, DCB. See triangle DCB? Then I think I'm going to use Pythagoras there. That is the case. And then I've got that. So those people who said the answer is 3 times square root of 55, they are correct. And then the others, just check where you made an error. And I think you can notice where you made an error there. But I see that most of you got it very right. You said CD equal to 3 times the square root of 55, because I used the information that is given and I used the triangle DCB, this triangle. This triangle is a right-angled triangle. So we used Pythagoras because we have got a right-angled triangle. Haldesos square root 55. DE, you said square root 55. Yes, Haldesos, let's see what is the length of DE. The other ones, what do you think the length of DE will be? What do you think the length of DE? Mwiponi also gave me the answer. Haldesos also gave the answer for the length of CD. Lelo also gave us the answer. What are others? They gave me the answer of square root 55 as the length of DE. Godfrey also says square root 55. Square root 55. And for the length of CD, what are others saying? What do you think is the square root of Ital says square root 55 for question 2. Let's see, we want the length now of, you are given that CD divided by DE equal to 3. Calculate the length of DE. The length of DE, so we must now find the length DE, this length DE, this one, that one. So most of you say square root of 55. Let's see what I got here. And I also got that. So I'm just going to clear the drawings and have this now normal. Okay, we are still using the same diagram. Let's see the answer that I got. Okay, that's what is given. I just rewrote what is given. For that, that's very good. You got it all right. DE is square root of 55. That's good. That's good. Because you see in this case, is CD divided by DE. But we already know CD, we calculated. So it's substitution and then cross multiplication. All right. Then I see Joy said 7.42. That's very good. Shamila also said square root 55. That's very good. Tal also said square root 55. That's very good, like the others. Okay. Let's look at the next question. Let's look at the next question. Let's try this one, ladies and gentlemen. All right. Study the diagram using the information which is given. Do we have the center? Yes, the center is O. Which chords are equal? AB, AC. No. The chords AB and AC are equal. Where is AB? AB, yeah, they are marked. You see that they are marked. So this chord equal to that chord. Once they say the chord are equal, so look for the base angles. Remember, in Euclidean geometry, you are given one part of the statement. You must complete the statement. Like I'm saying here, it's given that AB, chord AB equal to the chord AC. You might, for example, look at base angles, whether there are any base angles there. So CED, angle CED is 28 degrees. That's angle CED. CED is given as 28 degrees. And what else? ADB is given as 30 degrees. That's ADB. All right. So it's very important that you read the statement, and as you read the statement, you mark on the diagram. And as you mark on the diagram, you can already identify your theorems. You can already identify your theorems. And then in this case, because you are given a circle, so you anticipate to talk about circle theorems. Remember the circle theorems that we mentioned at the beginning. So let's see the questions. Calculate with results the sizes of the following angles. Angle E1, what is the size of angle E1? What is the size of angle E1? What is the size of angle A2? What is the size of angle F2? Angle E1 equal to how many degrees and why? And why do you say so? Aldezos, Miponi, they already gave me the answer. Ital, also Joy, they also gave me the answer. Okay, I see you gave me good answers. Very good. You are doing very well. You notice that with easy. So angle E1 is 90 degrees. Nyasha also says 90 degrees. That's very good. You are doing very well. So let's see the answer now. E1 is 90 degrees. Why is it 90 degrees? Because it is subtended by a diameter. Which diameter? FC. Do you see FC? FC, it's a diameter. Why do we say FC is a diameter? Because FC passes through the center of the circle. So that's E1 is 90 degrees. And remember, guys, once you have got the size of the angle in the question, write it down in the diagram, all right? Because you might need it to solve the questions that follow. Question 3, okay, that one, why is it E1? Why did I say is 30 degrees? E1, why did I say it's 30 degrees? Should be 90 degrees. 30 was subtended by the same, should be 90. Why did I say that? So it's E1 subtended by, oh yeah, here it must be 90, guys. Oh yeah, 90, not 30. The angle in the same segment. I got the reasons, just that I typed 30. So it must be 90, like you said. That's very good. It must be 90, like you said. I think I confused it with the 30 that I saw here. What about A2? Angle A2 will be equal to, this one we are saying is 90 degrees, yes. It's an angle in the semicircle. I think I wrote 930 because I saw 30 here. So A2, so this one we are saying is 90. This one is 90. And then A2, what will be the size of A2? A2 is this angle here. A2 is the angle at the circumference. What do you think the value of A2 will be? A2. So A2, how many degrees is A2? I've got that is the diameter there. What do you think the size of A2 is? Oh, the questions are coming. You're already responding. A2. What do you think A2 is? Oh, this thing that's right. A2 is how many degrees? Okay, I see the answers. All right, you're doing very well, guys. Ital, I see you're saying is 30 degrees. The others are saying 62 degrees. Oh, my mistake. Thank you, Ital. You noticed your mistake. Very good. Kahiso, Muyeng, 62 degrees. Muiponi, Poho, 62 degrees. Opposite angles of cyclic quad. Heldesos also says 62 degrees. They are opposite angles of the cyclic quad. That's what you are saying. Okay, Tala, maybe that you noticed the mistakes. Let me see the answer. Let's get the solution that I got. See whether I also got that. You see that E1, angle E1. Why do I continue to say angle E1 is 30 degrees when it's in the semicircle? It's 90 degrees. This guy here is 90 degrees. All right. So E1 is 90 degrees. And then, because it's an angle in the semicircle, we said that above. And then here I say angle E plus angle A2 is 180 degrees. Do you see that they are opposite angles of a cyclic quad? E plus A2, which means E1 here. The E that I'm referring to here is it's E1. So where is the cyclic quad? A2, or is the whole E? E is the whole E, not only E1, but the whole E. And the A2, you see that's the cyclic quad. So it assumes everything. So I'm just gonna use another color so that you can see the cyclic quad that we are talking about. That is the cyclic quad. So the cyclic quad is A, F, E, D, then A. Is a cyclic quad because all the 4 points are lying on the circle. It's E1 and E2. Say, yes, Aldoses, we are very good. Yes, it's E1 and E2. So it's the whole E. So it's the whole E. And then that is thank you, Aldoses, for noticing that. It's A, F, E, D. That's your cyclic quad, all right? And then we know that the opposite angles of a cyclic quad is equal to 180 degrees. And at the end, you have got A as 62 degrees. Thank you so much for getting the answer so correct. You are doing very, very well. Yeah, and let's see if there is any questions here. You see, if you see an angle at the circumference, you can check cyclic quad. You can check whether the angle is not formed by the same chord or the same arc. All those things must come forth. Remember, E1 is 90 degrees and not what I was saying here. I don't know why I keep on saying it's 30 degrees. Okay, let's proceed. Let's proceed, students. Okay, check this diagram now, and then let's answer the questions. I'm just gonna display the question already so that you can already try to find the answer to the question after reading the statement. After reading the statement, what do you think the answer is? What do you think the answer is in this case? Please work out the answer. Diagram below, a diameter of the circle with center O. So we have got a diameter. Remember, guys, once you have got a diameter, check the angle at the circumference, whether you don't have a 90. Then once you have got a diameter, we are likely to have a circle with center O. So that is the center of the circle. Then the diameter is AC. AC is a diameter. That's your AC. And then AC and chord BD intersect at E. That is the point of intersection. AB, BC, and AD are also chords of the circle. OD is joined, and AE. You see this information here. It's very important that you read. AE, where is AE? AE is perpendicular to BD. Ne? So this one is perpendicular. That's perpendicular. AE, perpendicular to BD. So it means that E1 is 90, E2 is 90, E3 is 90. So you are given that angle C is 33, guys. Angle C is 33. You see angle C. Angle C is 33. This angle here is 33. All right, what is the size of angle A1? You see the answers are coming. A1, Shamila. Some angles of triangle AED. Did everybody got the 57 degrees? See, Shamila says we use some angles of a triangle to get A1. Remember, A1 is this angle. You say is Joy also says 57 degrees. Lelo Masuku also says 57. Ore Kopanse also says 57. Naledi also says 57. Yeah, that's very good. I think that's the answer that I also obtained. I think that is also the answer that I obtained there. Where do I go now? Here. Let's see the solution that I have. Okay, E3 is 90. That is line from the center, and then P1 is 57. See this? All right. And then I proceeded like this. That is correct. You also agree with what I got there. Let's check if you agree with what I obtained there. Okay, Kakiso Nyasha also gave the answers as 57 degrees. So we agree with 57 degrees. So we agree with 57 degrees. Remember, once you get the answer, so A1 is 57 degrees, then I'm gonna put 57 degrees. Because remember, it's important that whatever answer that you find, you put it in because you might need it in your calculations. So A1 is 57, so you don't lose that. So this one we say is 57 because we are saying E3 is 90. So E3 is 90. This one is 90. Then B1 is 57 degrees because we said 90 plus 33, and then subtract it from 180 degrees because of the sum angles of the triangle. So this is also 57 degrees. So now, why do you say A1 is 57 degrees? So A1 is equal to B1 because they are subtended by the same arc, which is DC. All right, thank you so much. Let's move to the next one. Let's move to the next question. What is the next question? I'm just gonna put the next question here. We are still using the same diagram. What is the magnitude of 2D2? 2D2, already from the previous work, we already know that this is 57. Remember, we don't lose what we got because it might help us here. That's 57. We said this one also is 57. So this angle here is 90 degrees. This one here is 33, we know that. Okay, what is the size of angle of 2 twice D2? This one is 33. What else? And then we've got the diameter there. Twice D2. D1 also 33. Joy, you're saying D1 is also 33. Yes, D1 is also 33, Joy. That's very good. But we want twice D2. So this one is 33. You see it's 33 because it is subtended by the same arc. Do you see that? The arc AB. Joy, you are right. They are subtended by the arc this. So D1, yes, is 33. Then what is the size of D2? You see the arc AB subtend this. That is true. If you do that, you do that with your fingers. It's for the Muiponi. That's very good. So D2 is 24. I'm not sure if you all got that. D2 is 24. Muiponi, that's very good. What are others saying? Do you also find D2 as 24? D3 is that. And then remember that this angle here is also 90. Orokopans also say D2 is 24, so twice D2 is 48. Italia, that's very good. D2 is 24, so twice D2 will be 48. So I don't understand how you got Shamila. Yeah, I see some Shamila. I'm going to demonstrate that. Kagiso Moyeng, you say yes, it's 24. Okay, let's see then how we arrived there. Let's see how we arrived at these answers. Let's see how we arrived at the answers. Just gotta put this in normal and then. Okay, that's how I started. Do you agree that A1 equal to B1 subtended by the arc DC? That is what we found. We said these two angles here are the same. A1 and that other thing there, A1 and B1, they are 57. So those two, they are equal. That's how I approach that. You know that this one and that one, they are equal. And then what now? DOC is twice B1. DOC twice B1. You see DOC? Do you agree with DOC? Angle at the center, twice angle at the circumference. You might have taken a different route to arrive at the solution, but that's what I said here. That DOC, this angle here, remember is twice the one at the circumference. That angle there is twice B1. All right, there we are. And then now D2 is, you see D2 now, 90 degrees minus 66 degrees equal to 24 because E2 is 90. You see that we said that E2 is 90 because of that and that. So D2 will be 24 degrees. Okay. And then now I will say, therefore, twice D2 will be 48 degrees. So that is how I got the 48 degrees. That's how we got the 48 degrees. Okay. Right, let's see, let's erase that. Okay, yeah, Joy, yeah, that is that. Yeah, you are correct. Yes, it's easier if we say DOC is an exterior angle of a triangle. Yeah, no, that's correct. That's correct. DOC is an exterior angle of the triangle. That's quite correct, Joy. You can also state it that way. All right, let's move on. Show that AE bisects DAB. AE bisects DAE. What's the meaning of bisecting? Dividing into two equal parts. So we must show that AE bisects DAB. How do you show that? AE, where is AE? AE bisects DAB. DAB. So we show that, guys, here when they say show that AE bisects, remember bisecting is to cut into two equal parts. So it means that, would you just say that DE equal to EB? Yes, Shamila. Shamila Nkunda, AE bisects, you say not necessarily Shamila. Shamila, not necessarily DE. Okay, all right. You are trying to answer the question that this equal to that. Why do you say so? Would you just say that DE equal to EB? I'm not sure if I'm understanding the question, but to say that, I'm just gonna erase that thing there. But to say that AE bisects this angle, it means we must show that, what must we show? We must show that angle A1 equal to what? We must show that angle A1 equal to angle A2. That's bisecting, because by bisecting it means the straight line AE divides the angle DAB into two equal parts. So we must show that this angle equal to that angle. So that's what we mean when we say a straight line bisects an angle. So in this case, you must show us that angle A1 equal to angle A2. So one way of doing this traditionally is to take angle A1. That's just one of the approaches, but good. A2 is 57. Yeah, Orekopanze, I see you have got the answer already. Check what is A1 equal to, and then check whether angle A2 has got another angle that you might know that will be equal to this one. That's one way of proving that two angles are equal. How do we do that? You take, again here we want to show that A1 equal to A2. So what you can do basically is to say A1 equal to what? A2 equal to what? And then if these two are all of them equal to X, I'm just giving an example. Say you go on the diagram, you find that A1 equal to X, you find that A2 equal to X on the diagram, then it means that A1 equal to A2. Orokopanse already got the answer. He says A2 is 57, some angles of a triangle, but A1 is also 57. Naledi also got the answer. We are using 57. I think we've proved that before. I think in the previous questions you saw that. That is very good. You are doing very well. So the answers seems to be correct because we are using that argument of 57 degrees. And then to show that, here I'm explaining B2 is 33, A2 is 57. Kamogelo, I think you're also getting you are also getting it right. Here, I think I used, what did I use here? Equiangular, congruency. Let me see. I used congruency, which is still correct, because congruency also shows that the angles are equal, and therefore the AE bisects the AB. You see that I use the fact that the two triangles are congruent, which is fine. Or you can also take that root of 57, because we said this is 57, and that also is 57, and this one, how did others get A2 to be 57? I don't understand that. Because this one we said is 57. I still remember from the calculations that we did, we said that one is 57. We said this one also is 57. The other people who used 57, how did you get to A2 to be 57? Haldazos perpendicular to AE is common, therefore triangles are equal, therefore A1, therefore the things bisect. B2 is 33 naledi. B3 naledi, B2 33 naledi. I'm not sure why do you say B or B2? Okay, B2 is 33, and that, okay, because that's 90, and then this will be 33. That's what you are saying. Okay, no, this is not even 90. Oh, it's given, yeah, it's given that this one is 90, so all that is 90, but here you're saying 33. Why B2 equal to 33, naledi? I mean this angle equal to this angle. Why do you say P3? Okay, all right, because this is a diameter. All right, yeah, that is correct. That is correct. Yes, lady, that's correct. Yeah, that's correct. Yeah, that is just one way. Remember, in geometry we will have different methods. I used congruency here, which is still fine. And I saw that the majority of you, they use the fact that this angle A1 is 57, B1 is 57, and then B2 is 33 because AC is a diameter, like how Naledi did that question. That's very good. Let's go to the next question now. Let's see. I'm just gonna erase what I wrote there. Then we move on to the next question. That has been erased. Now let's move on. Activity 5. Let's complete the statement. Complete the statement. What is the answer? A line drawn parallel to one side of a triangle divides the other two sides. What do you think there? Remember, I said it's very important that you are, that's very good. Miponi, Haldezos, Joy, you got it right. Proportionally. Remember, it should be proportionally. Nyasha also says proportionally. Divide the two sides proportionally. That's very good. Shamila, Ital also, you gave me the correct answer. The correct answer is proportionally. The correct answer is proportionally. Let's see what I got here. They get that's proportionally. So you must be able, guys, to complete the theorem statement. Then activity 6, the diagram below, CG bisect that, prove with reasons that AD, AC equal to DC. How do you show that AC equal to DC? You must prove that Learners, you are doing very well, and I hope that you're gonna make it so well in the examination. This is D. I missed to write D here. So D is here. Excuse me. This is the angle D. Angle D, not B. That's angle D. Angle D. This guy here, this is your D. CG bisects ACB, ACB. The fact that CG bisects ACB, it means angle C2 equal to angle C1. Remember, bisects means dividing into two equal parts. And then we must show that the side AC, the side AC, no, it's not that one. The side AC, I'm not doing it right. So I'm just gonna study it again. I know that this angle here, C1 equal to C2. That's what we are given because of the term bisect. Then also, what do we know? Is it that one? AD is parallel to GD. Where is AD? Remember, D is this one. That's your D. So AD, this line here, AD is parallel to which line? GC. This is your GC. All right. Now remember, once they are parallel lines, so you are likely to have, you're likely to have alternating angles, corresponding angles, and so on and so on. You remember this diagram. Once you have got parallel lines, then check a transversal so that you remember you have 1, 2, remember 3, 4. You remember this thing, I think. This is very important, especially when you have lines that are parallel. So the other one will be 6, then that will be 7, then that will be 8. Remember, if you have got this, well, once they say the lines are parallel, you are likely to have that. I see that Kamogelo, you are in the right track. Then that is how I proved that. I think I also used that fact. I'm just going to show you here, normal, and then, excuse me, that is the solution that I got to prove that. But just erase everything there. I've explained that. See. So that's given. What's wrong with this? Just gonna remove that and then have this, okay. Corresponding angles, alternating angles. Yeah, like Kamogelo has said, that at the end you have got alternating angles, then you have got that one. And therefore AC equal to DC, sides opposite equal angles. That's how we end the class of today. Learners, I hope we were meeting in person, seeing your faces, but I'll say for these 4 days, I really enjoyed being with you. It was like we were together in a normal classroom. I would like to take this opportunity to thank each and every one of you and to wish you all the best in your final exams. I really enjoyed being with you for these 4 days. I hope that one day we will meet in person. Thank you so much. Have a lovely evening.